Hello everyone, this is Akash. I'll be explaining about my use case and I'll also be executing some SQL commands in Oracle based on real life examples. So let me get started. So the business case scenario or the application which I have designed is blood donation management system. So it is a database application which is integrated with the business case scenario of blood donation. It was first built usually as a website by me in the earlier days, and I actually developed more of the backend towards the later part of the year because I wanted to include more queries related to the database. So the main purpose of this business scenario is to save lives. Yes, the front end of this application provides e-information. E-information is nothing but the general information about blood donation, its process, needs, and the steps which have to be taken before and after blood donation, and what are the aftermath of blood donation and what are the precautions and who are eligible to donate blood. So the basic users, this is where I'm talking about the website, so where the users may get to see these information, general information. And this application also provides location of blood banks in India, so that they get to know where they have to go and donate or where they have to go and seek help when necessary. And whenever any customer requires blood immediately, their details is stored in the database. And similarly, a donor who is willing to donate blood can also enter the details through a form in the website, and this will get automatically stored in the database, that is the backend. So I'll be explaining the roles of different people. So first comes the role of admin. So this application has an admin page where the admin will be able to view the donor's information as well as the recipient's information. So only if he is authenticated, he has the correct username and password, he'll be able to see all this information and he can manipulate it, and he'll send these details of both donor and recipient to the blood banks, and the blood bank will later contact these donors or recipients according to the availability of the blood or the need of the blood. So this is the role of admin. So he can update, delete, view the donor and recipient details, and he can forward these details to the blood bank. Similarly, what is the role of the user? So by user here, I do not mean the general user who see the information that was just for the website, but the most significant thing in this application is the backend, that is the database. So here the user refers to donor and recipient. So the donor can fill up the donor form as I said earlier and the further process takes place after that. They enter the blood group and the details, and they can be contacted in need of emergency, and the recipient can fill up this recipient form so that their information is viewed by admin, and they can quickly forward it to the blood banks and find a suitable donor for them. So ultimately, both donors and recipients can also obtain general information which I talked about in the first slide. And so this is the basic thing. And what is the process that is followed in this application? So we know once the details of both donors and recipients have been entered, the admin can forward these details to the blood bank. So what is a blood bank? It is a center where the blood is collected, and this is a place where blood collection, processing, storage, testing is done. And after the data is passed on to the blood bank, they will contact the donor, as I told. So the motive behind, as I told earlier, is to help the people who are in need of blood and provide the donors and recipients details to the blood banks, and also to create awareness about the blood. Now I'll be explaining about the different entities. Entities are nothing but objects which have various attributes. So the different entities which I have got, there are totally 6 entities in my application or in my use case. The first one is blood donor, next is blood bank, blood recipient, donor recipient, receipt request, and blood. So let me explain the structure of each table or entity. The entity is also known as table. So let me explain the structure of each and every table. So this is the donor table. This is how donor enter the information, and those details are stored in this table. So each donor is given a donor ID. So what is this donor ID? I have also written it as primary key. So primary key is nothing but a key attribute which uniquely identifies a tuple or a record in a relation or a table. So if we have a student class, uh, we cannot identify which student it is only with the help of a name, because every person does not have unique name. Two different people or three different people can also have the same name. So that is why in school they provide roll numbers. Even in the college the same procedure is followed. So we need to uniquely identify each record. That is why we need a primary key here. So that is donor ID. And the gender and the basic details like gender, name, age, email, weight, address are stored. And then the disease, if they have any disease, I've taken it as yes or no. That is why I've given it as varchar 3. So this is the column name. Data type is varchar. Varchar stores the letters or the strings, whereas number, it stores the integer number or floating number. Similarly, tablets, disease and tablets are both similar. If you have any disease, you tell yes, or else you tell no, or else you can also write it like 1 or 0, but here I've gone with yes or no. And donor phone and blood group, these are the details that donor has to provide. In the next entity, this is called blood table. So we have donor ID, and this is called as the foreign key. So what is this foreign key? Foreign key is an attribute in a table which references some other column in a different table. So whatever value is there in that particular table, only if the value is present in that column of that table, the value which is inputted here will be accepted. So here donor ID, if you remember, we saw this donor ID in the last table, donor table, which is the primary key. So only if a attribute is a primary key in one table, it can be a foreign key in another table. So here donor ID uniquely identifies a record, and only if that donor ID, if a particular value is present here, it will be inputted here, because unregistered donors cannot pop up from somewhere, and they cannot be included in this blood table. So this blood table is to store the blood code. Blood code is a primary key here, because we need to know what blood sample is collected, and the blood bank ID, which blood bank ID is managing this transaction, and the amount of quantity donated by the donor. So that is what is the blood table. It stores the details of the blood or the blood which is collected, and the blood bank ID which is handling or managing this, and the blood code which is used to uniquely identify it. So I hope that that explains well about blood table. And the next one is blood bank table. So there are lots of blood banks, like more than 200 blood banks in India, and there are actually more than that, which actually manage the donation of blood to recipients via donors. So we have the blood bank ID. BBID is the primary key, which again uniquely identifies this record, and we have the name and the address. So here I've also used another constraint called not null everywhere. So not null specifies that we cannot enter a null value, because all the details which are entered into this application are important, and we cannot afford to have a null value everywhere. So whenever not null is specified, we cannot enter a null value. And primary key is both unique and not null. It should also not be null, and it should also be unique. We cannot repeat the same value again, because then only it will be possible for us to uniquely identify the record. Next is the recipient table, where recipients fill the forms, and their details are stored. So the same thing as donor, their ID, gender, name, these details are stored, and then blood group is also stored. And then the next entity is recipient donor, where we combine both these recipient and donor table, because we need to know where how this transaction is taking place, who is donating to whom, and which blood bank is handling it, and which is the blood sample that is used. So for that we use blood code, which is the foreign key. We also have the donor ID to identify who the donor is. We also have the RID, which is the recipient ID, to identify who the recipient is. And we have donation ID as the primary key, because we need to have a separate list of how many donations are done and to uniquely identify each donation. And we have BBID, which blood bank is managing it, and R date is the date on which the donation is done, which is not null. And the last entity is receipt request. So we have to know when a particular request from a recipient has been made, and what is the date on which it was made, and how much quantity of request has been made, so that it can be further dealt into further processes. So RID, we have the quantity requested, the date on which it was requested, and request ID. So in the previous entity we had R date. R date is on the date which donation was done. Here the date requested is nothing but the date on which the recipient has requested. So this blood donation management system is designed with ultimate aim to save lives, as I've already told, and it can be used in hospitals and various other blood donation programs as well. So now I would like to execute the queries and show relating to the real life examples. So let me quickly switch to that. So this is the Oracle database management system where I have executed a lot of queries. So first I have created this table. This is the donor table we was talking about. So create table is the command to create it, and this is the name of the column, this is the data type, and this is the constraint. So if we want to make it as a primary key, we give the constraint, the name of the constraint, and if it is primary key or not null. So this is what is followed throughout all the creation of tables. So after creating, we can use this DESC to check the structure of the table. So here it is visible, the structure of the table is visible, this donor ID, gender, donor name, etc. Similarly, I have created the blood, BB, recipient, receipt donor, and receipt request tables. And alter table is used when we want to modify a column name, or if we want to modify data type, or add a new column, or add a new constraint, or if you want to drop any table or drop any constraint. So alter is nothing but a DDL command, which is data definition language, which deals with the structure of tables and their database schema alone, whereas DML is data manipulation language, which deals with updating or deleting the data or manipulating the data on the whole. So these are the different tables which I've recently showed. So to explain it more clearly, let me show you the ER diagram, which will make the scene make this thing more clear. So here I have the donor table who donates blood, and the blood sample is collected in the blood table, and the recipient requests blood, and if any donor has donated blood sample, the recipient will take it from there, and the blood bank, which is here, contacts the recipient and donor in need or when necessary, and it also manages the receipt donor. So receipt donor is a combination of both recipient and donor table, and recipient requests the details stored. So request details stored it will be in the receipt request table. And yeah, the blood bank manages the receipt donor, and this is how the overall ER diagram looks. We can also add the attributes, but it would attributes for each and every entity, but it would look a bit congested. That's why I chose to only have the entities and the relationship that we have. So let me quickly jump to the SQL queries that I have done. So the first query is for there will be many real life examples for this. So I have taken like 5 to 6 queries which can be done using this database, which can be manipulated and utilized. So the first question is, for each blood group, we have to display the number of donors, the name of donors separated by colon when recipient ID is provided during runtime. So we have a recipient ID, as I told now. So if we provide that during the runtime, for each recipient ID, we'll have a recipient, and that recipient will have a blood group. And for that blood group, we have to output how many number of donors are there with the same blood group, and who are the donors. The name of the donors we want it with separated with colon. So this is the code for that. So select D blood group, select the blood group. List aggregation aggregates the donor name with the help of a colon. So it is slightly different from group by function, which we have used here. Group by actually reduces the number of rows, but here in list aggregation we have the same number of rows as we already have, but the only thing is it performs the addition or average or whatever thing we give, and it displays the output for all the rows. So after separating with a comma, it will display all the names here, and we have grouped and we have ordered it by blood group. So this one we are selecting it as name of donors, and next we also need the number of donors. So we are selecting the count, and this is a subquery which is used here. Select donor from donor D, join recipient R. So this is the join operator because we are using data from two different tables, donor and recipient. So if the recipient blood group should match the donor blood group, so we are using this. So that donor ID we want. So whenever recipient ID equals donor, recipient blood group equals donor blood group, we want that donor ID, and how much such donor IDs are available, that is what we are selecting. That is what is nothing but the number of donors. We have already written the query for name of donors, and where RID equal to and recipient number. So and ampersand is nothing but to input the value from the user during the runtime. So if we don't give ampersand, we won't be able to give the input during the runtime, and we are grouping it by blood group. So let me run this code, run this query. So this is the recipient number which I have. So if I give R0004, the blood group that recipient ID is A negative, and the number of donors is 2, and who are those? The name of donor is Ishwar and Omkar. So let me try giving another. So if I try giving 5, it is AB negative, and there is only one donor for AB negative, and the name of the donor is Lakshmi. So this is a query for the first one, and then moving on to the second one. So the next query is on giving request number. We have to check if the donation is completed yet or not. If yes, on which date. So I have used a concept called NBL. NBL is nothing but if a query returns null value, instead of that we can give a default value. So the default value which I have given here is donation not yet done. So if this one returns null, this subquery returns null, then this will be printed. So we need to check if the donation is completed or not for a given request number. If yes, on which date. So we already know that for a receipt request, we have all the requests which are requested by the recipient, and in receipt donor, if the donation is completed, we do have a column of RID, which is the recipient ID. So I have written select NVL, and we need to give the date we cannot directly convert it to date. We have to convert it into character. So select to care of our date, and we want it in this format from the receipt donor. So we already know we are giving only the request ID. So request ID and is present in the receipt request table, and we are selecting the RID from that because we have to match it to this. So we are actually checking the RID in receipt donor and receipt request. So if it is there in receipt request and if it is not there in receipt donor, then the donation has not been completed yet. So that is what the code is from receipt donor, where RID is, we are selecting RID from receipt request, where RID is, again we have another subquery, and this is the NVL. So donation is not yet done if it is not present. And uh, for selecting date and all, we cannot simply give a select 2 into 5 or select 8. We have to call call from another object called dual. So let me run this code or run this query. So I have to give the request ID. So this request ID, the donation has not been completed yet. So for this request ID, there has not been any donation done. So if I try to give some other request ID, like let me try giving 01. Here the donation is already done. So if the donation is completed, the date is being printed. So this was the second query. And the third query is blood request is received, but if pending for more than 10 days. So here I've used a set operation called minus. So minus is a set operation that returns the things which are there in table A but not present in table B. So here I'm selecting the RID in the subquery. I'm selecting the RID from recipient request, and here I'm selecting RID from recipient donor. So what is present in recipient request, not present in recipient donor, is the thing which is pending, that is donation is not yet completed. So I am selecting all the columns, and sysdate gives the current date. Sysdate minus date request. So this is the date on which it was requested, and if it is greater than 10, it has to display the RID, the date on which it was requested, and the quantity requested. So I'll run this. So as of now there is only one record here, and regarding how I filled all these details, I used the insert into donor values. This is the query to insert. I inserted one or two values using this, and as the amount of data was very large, very colossal, I used the data loading option which is available here. And the fourth query is I have just used joins here to display the use of join. We have to get the blood bank ID, blood bank name, address, and total quantity donated. So all these things are in different tables, not in one table. So in order to get that, I have used join here. So BB. So this is the table name or the entity name, because two tables or two entities can have the same column or attribute. So we have specified that, and sum of the quantity donated, it adds all the quantity donated, and we have done partition by BBID. So it is nothing but grouping by BBID, but for all the records the same value will be printed, the same value. So if there are two records with same number as 10, so for 10, if the output after grouping is 20 for both the records, it will be 10 20, and even in the next record it will be 10 and the output will be 20. Whereas for group by, it will print only once. So yeah, this is nothing but number of units donated, and I have joined it. And on the condition, because the common column here is BBID, so if this is equal, we have to select this, and distinct ensures that only unique values are selected and duplicate entries are not selected. So this is the output. So BBID, the blood bank ID, name, address, and number of units donated. And the fifth query is we have to find the top 5 blood banks which have fulfilled the most number of units. So I've selected BBID, sum of quantity donated. As we have seen, it keeps adding the number of quantity donated because we have grouped by BBID. So according to blood bank ID only, it is going to group and order by sum and the descending order. So the highest whichever has donated will come first. But if we don't include this last line, it will display all the blood banks which are present, but we want only the top 5. So I have included this fetch next 5 rows only, so it will fetch only 5 rows. So yeah, so before this I had selected so if I select only this, it will display 10 records, that is how much ever is present. But if I also include it, it will display only 5 records. And the last query which I have designed is check the donor ID, name, and blood group of donors who have registered and have donated. So those who have registered and have donated, those donors name and their details should be printed. So donor ID, name, and blood group we are selecting from donor, where donor ID in so the subquery is we are selecting. So again I'm using a set operation intersect. So if the donor ID is present both in donor, because blood we know is the blood sample of the donor. So if we have the blood sample of a particular donor ID, we know that donation has taken place and it has been donated by the person of that particular blood donor ID. So if it is present, donor ID is present both in donor and blood, then they have registered and have also donated. So I'm selecting using the where clause donor ID if the donor ID is present in both the tables. So if I execute this, I'll get so actually there are 11 records and only 10 of them have registered and have donated. So, thus these were the 6 queries, and using the database and backend, we can have a myriad of solutions like this. Myriad of applications can be built upon. And thank you so much for watching.